Today we discuss about logic, planning and knowledge in AI. Logic, planning and knowledge in AI. These are all the topics are in logic, planning and knowledge in AI. Logic, planning and knowledge in AI, classical planning in AI, advanced planning concepts. Introduction to intelligence agent and AI. Defining intelligent agents. Intelligence agents perceive environments that then act purposefully to maximize their chances of achieving predefined goals. AI core objective. Artificial intelligence central objective is to engineer systems embodying such intelligent agency for problem solving. Logical and planning rules. Logical facilitates knowledge representation and reasoning. Knowledge-based agents. Knowledge-based foundation comprises a knowledge base and inference engine enabling structured environmental understanding and action. Formal knowledge representation. The KB. It's nothing but knowledge base. Stores facts as formal language sentences representing world state for agent reasoning. Rational inference engine. The inference engine uses logical to deduce new knowledge, selecting actions, maximizing expected utility. Propositional logic. Syntax fundamentals. Semantics explain. Truth tables and evaluation. Let us see one by one. Syntax fundamentals. So we are using propositional logic syntax. Uses atomic prepositions like a PQ. So their connectives and are not implies. Semantic explained. So semantics assigns precise truth values like true or false. Truth tables and evaluation. Truth tables systematically evaluate complex sentences from atomic component truth values like P and Q. Propositional theorem proving. Entailment determination. Theorem proving aims to determine if a sentence is logically entailed by a knowledge space. Inference rules. Inference rules like modus ponens and elimination systematically derive new sentences from existing ones. Soundness and completeness. Soundness ensures inference rules yield only entailed sentences. Completeness guarantees all entailed sentences are derivable. Propositional model checking. Defining a propositional model, a model assigns truth values to all atomic propositions representing a possible world state. Model checking process systematically evaluates a propositional sentence truth across all possible models for validity. Semantic versus syntactic methods. Model checking is semantic, theorem proving is syntactic, both complete for propositional entailment determination. Agents using propositional logic. Percepts and knowledge-based integration. Agents incorporates environmental percepts into their knowledge base, which contains propositional logic rules for decision making. Inference for action selection. The inference engine systematically queries the knowledge base, leveraging logical entailment to deduce optimal actions. Vacuum agent example. Vacuum agents rules like dirty, suck illustrate logical encoding of environmental conditions into agent actions. First order logic, syntax and semantics. First order logic expressive power, unlike propositional logic, FOL expresses relationship between objects and quantifies over them. Key syntactic elements. Syntax includes constants, for example, constants John's, predicates likes John, Mary, functions mother of John, and quantifiers like this. Interpreting FOL sentences. Semantics defines truth values for FOL sentences based on interpretation within a specified model. FOL inferences, chaining and resolution. Unification role finds substitutions, making FOL expressions identical, crucial for successful logical pattern matching. Forward changing, data driven, derives new facts from existing knowledge until goal reached. Backward changing and resolution. Backward changing is goal driven, resolution within unification, scolomization. Is refutations complete for FOL. Knowledge representation and engineering. Defining knowledge representation. Knowledge representation encodes information into formal languages, enabling AI systems to perform logical reasoning. KR goals. Knowledge representation primary goals are expressiveness, allowing complex relations, inference efficiency for practical use, and learnability by machines. Knowledge engineering process. Knowledge engineering builds and maintain and utilize the knowledge base involving domain analysis, formalizations, and testing stages. Ontological engineering and advanced KR. Defining ontology. Ontology formally specifies a shared conceptualization of a domain, delineating categories, objects, and relationship, representing mental objects. Mental objects like beliefs, desires, utilize model logic. Events like actions, occurrence, model temporal and causal relations. Default reasoning. Incomplete knowledge is managed via default reasoning, making assumptions unless explicitly contradicted by evidence. Classical planning in AI. Defining classical planning finds an action sequence in deterministic, static, fully observable, and known environments to achieve goals. Planning as such views planning as state space search. Whole configurations are states